Google IP address range calculator, and you can find a lot of information, a lot of tools out there. Click the first one and asks you to give the network address, and then it will give you the minimum IP and the maximum IP. We'll provide the network address which we have used in our example is 54.92.0.0/20, and if you try to calculate, the minimum IP address is 54.92.0.1 and the maximum IP address of the host can be 54.92.15.254. That's what we have seen in our example also. So this is the range which we used our method to calculate out. Let's try to find out the IP address range for this network address, which was our third example. Paste the network address and the CIDR notation, then click on calculate. So the minimum IP address is 52.26.12.1 and the maximum is 52.26.12.14. That was our output as well. Of course, the first one is for router's private IP and the last one is for broadcast IP. So the minimum usable IP would be 52.26.12.1 and 52.26.12.15. That is the maximum usable private IP. That's what we are seeing in the tool also. So just Google it, IP address range calculator, and you'll find a lot of tools out there. Subnet is actually called subnetwork, which means small networks inside of a network or subdivision of networks. Subnet divides a large network into smaller logical networks. For example, this is your main router, which has been divided into two smaller subnetworks, Subnet 1 and Subnet 2. The subnets are logical, they do not contain physical routers. Each subnet is a separate network on its own. Machines in one subnet cannot talk to machines in other subnet directly. Even though it is logical, machines behind a subnet cannot talk to each other directly. They have to go via the router. To create a subnet ID or subnet address, network address needs to be extended by penetrating into host bits. If this is the network address, we have 16 bits for network and 16 bits for host machines. To create subnets, we'll have to divide this network address further, which can only be done using some bits allocated for host. So we have 16 bits allocated for hosts. These two are available. These are the subnetwork address. If you see, the subnet addresses have extended the network address to 24 bits. And we only have 8 bits available per subnet for the hosts. /24 is smaller than /16 because /16 can accommodate more hosts than /24. We could use this address because if you see, the minimum IP address for this network address would be 52.26.0.0 to 52.26.255.255. So 52.26.10.0 and 52.26.2.0 fall within the usable IP address range, and we have added the network portion here. So this is our subnetwork address. Final topic of discussion in the pre-VPC talk is firewall. Firewalls are very important for security reasons. Every enterprise network should implement firewall, come what may. Let's go for a firewall ride. Firewall is a system made to prevent unauthorized traffic to and from your private network or computer or server by allowing or denying those traffic. Allowing and denying traffic are mentioned by rules, also called firewall rules. This is your machine or server or host, whatever you might call it. Firewall is placed in front of hosts or network routers. Using this firewall, you can allow some traffic to come and connect to your host. The rules are placed inside of these firewalls, and some traffic can be denied access or connection. Request and response. Requests and responses are needed to create firewall rules. Please pay very close attention here because you'll be using this concept in VPC security groups and network ACLs. Let me try to explain requests and responses using phone analogy. If I have your phone number and give you a call, the first word which I would say is hello. Actually, I'm sending a request to you, asking you to talk to me or reply me. and wait for your response. How do you respond? You say hello to, considering that you could hear my hello. Once I receive your response, I start talking about other stuff like how's the weather and etc. And you reply to all my queries or requests. This is how entire network works. Every machine sends requests to other machines and waits for their responses. Request and response play a very important role in network communication. Let's see an example now. We have a blue and a yellow and a red host. We'll consider blue host as the system or the center, and the requirement is to place firewall rules for this blue host. So requests and responses would be considered as per this blue host because we are planning to place firewall rules here. So all requests and responses would be with respect to this system. If yellow host is requesting something from this blue host, say to download a file, then that's an inbound request from yellow host, inbound to this blue host. When blue host sends a response back saying that you can go ahead and download, that's an outbound response from the blue host. So the inbound request is coming into the blue host and the outbound response is going out of the blue host. Similarly, when the blue host sends a request to the red host, that's an outbound request from blue host. And red host sends a response back, that's an inbound response to the blue host. All these requests and responses have been defined with respect to the blue host because we want to place firewall rules for this host. Requests and responses are tied together to a single host or network. They work as a couple to a single machine. For example, we are getting inbound request from this yellow host and sending outbound response to this one. So the firewall rules would be tied to this request and response to the same yellow host. Having explained requests and responses, let's see the type of firewalls. First one is stateful. So it says that no additional rules are needed for response traffic. In stateful firewall, you only define rules for request traffic. No rules are needed for response. These are the same hosts, but we have placed firewall in front of the blue host. If we allow inbound request from yellow, then outbound response for that request is allowed by default. I hope it is clear. Let me repeat. If you allow inbound request from yellow host to this host, then outbound response to this host is allowed by default. This allow rule is placed inside of this firewall. On the other hand, if we allow outbound request to yellow, inbound response for that request from yellow host is allowed by default. Remember, we are creating rules for the blue host. Second type is stateless. Firewall rules have to be mentioned for both requests and responses. With the same example, if we allow inbound request from yellow, then outbound response for that request has to be allowed explicitly in the rules. Let me repeat. You're allowing inbound request from yellow host to blue host. So you have placed a rule for this inbound request in the firewall. If you're planning to allow outbound responses from blue host to yellow host for this request, the rule has to be placed for outbound responses also in the firewall rules. Typically, stateless firewall rules are placed in front of network router or in subnets, whereas stateful firewall rules are placed in front of hosts or servers. Let's summarize what we have talked so far. So we have seen how home network works. We have also seen what are routers and its multiple components. We have taken a deep dive into IP address, CIDR notation, CIDR classes, and IP address ranges. We have talked about requests and responses. Finally, we spoke about stateful and stateless firewalls. I hope all concepts which I have mentioned in this pre-VPC talk are clear. If not, please go through the video again. These are very much needed to understand VPC.